Well, Antarctica is a very big continent. But before I take you to the journey of Antarctica today, there are some couple of caveats before I begin my talk. Number one, that this is a very journal presentation meant for very journal public as well as students. I hope that scientists would also appreciate it. I'm not an expert on Antarctica. Nevertheless, it's a privilege of working at this center and taking care of Antarctic science. Another thing before I begin the presentation is this presentation cannot be complete in any form because Antarctica is huge, so please take it with a pinch of salt. So I'm Rahul Mohan from the National Center for Polar and Ocean Research, a key component of the Ministry of Earth Sciences, and we are situated in Goa. Well, I'm a geologist by my degree, and by training, I'm a paleoclimatologist. I look into microfossils. Okay, so let me take you to the icy continent. So sit back and relax when I show you what Antarctica is and how do we go there, what do we do. So today's talk outline is looking at Antarctic history, the geological history, looking at changing climate and its repercussions in Antarctica, some bit of Antarctic scientific expedition, which involves the Indian Antarctic Program, the Antarctic challenges, and of course, the Antarctic flora and fauna. So let's see where Antarctica is placed. Well, if you see that Earth, as you all know, is an ocean planet. Water is in all the three forms in the cryospheric regions: liquid, gases, and solid. Solid in the form of ice and snow. And they are present in Antarctic at the rock bottom of the globe, or in the Arctic Ocean up above, or also in the Greenland, Iceland region. Apart from that, the mighty mountains. So when you look at the two globes that I have placed, what you see is that Antarctica is diagrammatically opposite to the Arctic Ocean. These are sometimes called as antipodes. Well, when you look at Antarctica, it can be divided into two parts by the Transantarctic Mountains. So if these are the Transantarctic Mountains, this is West Antarctica and this is East Antarctica. More about Antarctica in the slides to come. But before I tell you how cold Antarctica is, how windy Antarctica is, how is Antarctica today, let's also understand the Antarctic history. Antarctic history is very rich and a very big one. There are volumes written on this, but I'll take few minutes of your time to brief you on the legacy of Antarctica. So the Greeks, and this is one of the early maps which probably were done by the Greeks in 350 BC. Greeks knew Arctic as Arctos, and that is the bear from the great constellation. And they thought that there is a land opposite to Arctic, which is balancing Arctic, and they called it Antarcticos, that is opposite of Arctic. Well, Antarctica, as many of you would have read, that it's Terra Australis Incognita, the unknown southern land. And let's now look at who were the early explorers. In 1773, Captain James Cook, a British explorer, was the first human to cross the Antarctic Circle, or rather I would say circumnavigate Antarctica. But he could never see the land. And he made a remark that world will derive no benefit. I am sure that world has derived enough benefit from Antarctica. Another sailor from the Russian Navy, that is Bellinghausen, Perhaps he was the first one who spotted Antarctica, and this was recorded as the first sighting of the continent. And this also led, the logbooks of these sailors also led to the seal hunters uh, moving ahead towards Antarctica, because seal hunting was for their fat and the blubber that they have. And from Bellinghausen, I'll take you to a story which is so well known. That is the race to the South Pole. Well, the Norwegian explorer Roald Amundsen was the one who started his journey in 1911, October 18th, and he and his 5 men, along with 52 huskies, that those are dogs, powerful dogs, and 3 tons of supplies, started for the South Pole. They reached the South Pole in 1911 December, that is 14th of December. However, along with Roald Amundsen, a British named as Robert Falcon Scott was also preparing to go to Antarctica. So he left his base around November 1911, and he could reach the South Pole by 17 January 1912. So he was accompanied by 17 men and 1 ton of supplies, and I'm sure with some huskies as well. However, to his disappointment, the Norwegian Roald Amundsen and his team had already reached before him. This was a setback to Robert Falcon Scott, and he was depressed. However, while returning, Robert Falcon Scott and his team were caught in a big windy situation, often referred to as blizzard in Antarctica, and that left his team surviving for 3 days, and beyond that they couldn't, and they perished some 12 miles away from the hub that they had made for the supplies. However, it was also in 1902 that Robert Falcon Scott, along with his team, had attempted to reach Antarctica. However, they had to return back when they were few hundred miles away because of scurvy, that is vitamin C deficiencies. For those sailors who go on ships would realize that every morning you are given lime juice, for the simple reason that you require to have vitamin C when traveling on sea. So this was one of the heroic phases, and then you have another British sailor who sailed with Robert Falcon Scott in 1902, and this time Ernest Henry Shackleton decided that he would take the ship Endurance and would like to cross Antarctica.
The Endurance loses her final struggle.
But his goal was not attained. This was Antarctica's greatest adventure ever. The ship was crushed in sea ice badly. These were wooden ships, mind it, and very frugal engine with single engine. However, the team of Ernest Shackleton could survive because they had emergency boats. They could go to a nearby island, which was known as the Elephant Island, and they stayed there for 2 long years. Okay, so now coming to our hero of today's presentation, and that's Antarctica, the frozen continent. I call it the big refrigerator of the globe. Well, many people use Antarctica and Antarctic quite often. For some, it may sound very silly, but I would like to introduce that whenever you are using Antarctica, it's a very proper noun for the continent. And when you are using Antarctic, it's an adjective for South Polar regions, which includes island and southern oceanic regions. So let's see, how big is Antarctica? Antarctica is quite big. So you can fit in full North America and India, and then you will have still spaces to accommodate some more island nations. So it's about 14 million square kilometers with 98% ice sheet, and that accounts for about 90% of the world's ice. It's also interesting that Antarctica doesn't remain like this. It grows. Yes, it grows. Every year, Antarctica grows during the winter. And you can see the timeline here, the winter months. So each winter, it doubles itself. So seawater freezes. With the freezing of seawater, there is release of salts. And because of that, there are brine channels forming. And in these brine channels live different organisms. So sea ice has a lot of role in the climate, be it the albedo or the life forms that they harbor, which are important for the animals that live in the Southern Ocean. So you've seen the comparison of winter and sea ice extent. So now let's see how cold is this place. Antarctica, everyone knows, is very cold, but how cold? Uh, the coldest continent on Earth with the mean annual temperatures of minus 35 degrees C. This is Vostok, a polar plateau station, the Russian station, famous Russian station, which recorded minus 89 degrees centigrade. And this is an interesting picture, a person holding a bowl of spaghetti with a fork, which is frozen in midair. Such is the temperature profile there. Once we have known that how cold it is, now let's look how windy it is. Well, winds pick up anytime in Antarctica. Anytime means you know that you can be caught. And therefore, in Antarctica, you're always told that you have to go with a buddy. You cannot go alone. And there have been numerous instances of people getting lost and perishing in Antarctica because they tried solo. But this is some care that you need to take. And wind speeds of 100 to 200 kilometers per hour is normal. So the recent cyclone Amphan, that was 222 kilometers per hour as per records, that destroyed parts of Bengal and also parts of Orissa. So this type of winds are very common in Antarctica. So why these winds are so strong in Antarctica? The reason being the polar plateau is full of thick ice sheet and there is heavy cooling there. So normally what you see is when you go to from Delhi to Nainital or Delhi to Mussoorie, you will start feeling cold. But in this situation, when it is super cold, so the air above is little warmer than the plateau itself. So this cool air, very, very cold, dense air, tries to rush towards the coastal regions because it is warmer. The coast is definitely warmer. So they rush. And the second is there are lows all around Antarctica that are there. And that is the circumpolar trough regions where the lows are there. And it is always captain's nightmare to somehow avoid these high pressure zones while going to Antarctica. In Hindi, sometimes we used to call that पिशाची वहां पर बैठा है तो उधर ध्यान से जाना है. Anyway, so now let's look at the elevation. Antarctica is the highest elevated continent on the globe. So average elevation is about 2.4 kilometers, and some places it can also reach about 4 kilometers height or thickness. So about 90% of the world's ice and 70% of the world's fresh water. So ice is just fresh water, and you need to remember this time and again. I'll be referring to this. So if you have a look at the cross section of Antarctica, this is East Antarctica, this is West Antarctica with less thicker ice sheet, and East Antarctica with thick ice sheets. And you would see that this is more than 4 kilometers, whereas this is about 1.2, 1.3. So this is the difference. And now an important thing, which we are all worried about. What if Antarctica melts? This is a question in everyone's mind. First of all, let me assure you that Antarctica is not going to melt so soon. So be sure and do not get panicky about it. But yes, if Antarctica melts, then you would have a sea level rise about 58 meters. The height of India Gate is about 42 meters. So you can just imagine that whole of ice, if it is removed from Antarctica, there will be a sea level rise of about 58 meters. But what will happen to Antarctica? Will it sink? So this is a question that I leave it up to you, because all the matter on the top is removed. So will Antarctica also sink? It will not. So food for thought for you all. Looking at the temperature profile, the sea surface temperature profile of the world oceans, what you see here is all in red and yellow tropics. This is pretty warm, and you can see about 28 degrees C, and closer to Antarctica is -2. Southern Ocean is about +2. So what does it do? This temperature difference drives ocean currents, and secondly, these cold oceans, that is the Southern Ocean, picks up or stores a lot of carbon dioxide. Therefore, Southern Ocean is sometimes also referred by many as lungs of our planet. And I thought that I should refer this because we are in COVID times, so we need to take care of our lungs, and therefore we need to take care of Antarctica and Southern Ocean as well. So let me introduce you to something that you all may have heard of. That's the mightiest current on the globe. All rivers combined, this is the mightiest, and flowing from west to east. This is also known as the west wind drift that happens. And because of this, Antarctica is also cushioned. But this is not the only thing that I wanted to show you in this animation. I also wanted to tell you that this acts like a refrigerator door. So the heat is, the cool air is being stopped by the refrigerator door. Antarctica is a huge refrigerator, I had told you earlier. And so the cold waters of Antarctica, because of sea ice all around in the winter, also generates density driven currents. Those are also known as thermohaline circulation, because a lot of salt is given out when the sea ice is being formed. So where will the salt go? The salt has to go back into the water, or certain salt remains as brine channels, in which again some microalgae in tube forms live there and thrive till they get another season to prosper. So was Antarctica this cold? Question, a big question. No, Antarctica was not this cold. When we look at the remains of the 90 million year old rainforest discovered under Antarctic ice, we feel that Antarctica was not this cold. And I'll give you more examples of why Antarctica was not cold in subsequent slide. But first, let us understand the Earth's history. This is the geological time scale, and I'm not going to talk on this. And Earth, all the continents were joined together, and this was known as Pangaea, surrounded by one ocean, that was Panthalassa. So this started separating about 150 to 152 million years ago. So when did the ice sheets appear in Antarctica? This figure, which on the x-axis you can see the time in million years, and these are global surface temperatures computed, and This red line is also the CO2 fluctuations that have happened in the past. So this is the Cenozoic era that is here, from Paleocene to Holocene to Anthropocene, in which we are staying now. So this curve that you see has come down, and they say that it could have been the decrease in carbon dioxide. But was it only the decrease of carbon dioxide that led to Antarctic glaciation around 35 million years ago? Whereas the Arctic glaciated much less time. It was just 4 to 5 million years ago. So having known when did the Antarctic ice sheets glaciated, now let's look at what are the possible things that would have happened. Scott's paper in 2015 has reviewed all the literature available which has been derived using uh, ocean sediments. So what must have happened? There could have been the opening of the ocean gateways, the opening of the Tasman Gateway. The Tasman Gateway opened about 50 million years ago. And there was another gateway that opened, that was the Drake Passage, which connected South America to Antarctica. With this opening of the ocean gateways, we have the increased current velocities that are driven by the westerlies, and then the ACC gets going. So you have increased upwelling. With that, an increased biological pump, that is the phytoplankton and the zooplankton activity starts, because they start getting the nutrients on the surface of the ocean. What do? They sequester carbon dioxide. What it does, it cools the SSTs, and the other reasons for Antarctic glaciation could also be obliquity and eccentricity minima. As you know that the Earth is tilted at an axis and it wobbles, and that could also lead to glaciation. Then of course, once the ice sets in, then you have the albedo effect. But how do we know all this story? For that, these are protist, pinhead size, and these are made up of calcium carbonate, that is tuna, CaCO3. These are benthic forms that are deep dwelling, whereas these are planktic foraminifers that are surface dwelling. So these foraminifers, because they have that O, you can do stable isotopes of to find out temperature. So you can have the ratios of 18O versus 16O. 16O is a lighter isotope, 18O is a heavier isotope. So when, supposing in tropics you have heat, so what will be the isotope that will get evaporated because it is lighter? O16. So the ocean will get richer in O18. But it is not so simple. There is also preferential taking of O18. So you can find out the ratios because these tests are secreted in equilibrium with the ocean water with a certain caveats. And so you could know the temperature, and also you can know the isotopic ratios of the ocean water. But there are problems related to this, which I'm not talking now because there'll be some more talks later. So people started looking at magnesium by calcium ratio. So magnesium also gets incorporated in the test of these foraminifers. Whenever there is warm SSTs, you get more of magnesium compared to calcium. And knowing these ratios, again, you would be able to decipher the past temperatures. There is a new proxy that is being used for last decade or so, and that is barium, through which you can also know about carbon dioxide and the past pHs. Both these analyses are being done by two different groups at NCPOR very effectively, and we are generating a lot of data on temperature as well as trying to put up the pH based on boron. Okay, so now let me show you an animation. Or before that animation, I would just like to tell you about the sea ice. when you look at, you have looked at sea ice, but if you would like to know the sea ice extent, what you would look for, then you don't have foraminifers preserved in sea ice. Then you would need to look at sea ice diatoms. These are siliceous uh, frustules, they are called frustules, and they are very beautiful and intricate, and it's a love to see them under the microscope. So if you take out a sediment core in close to Antarctica, you will get a mix of open ocean diatoms and sea ice diatoms. And therefore, you would have a relative abundance of warm and cold. But then you can also get fast temperatures using diatoms, using transfer functions. So now let's look at the animation and just keep your eye on the numbers here. It's moving pretty fast and the continents are getting arranged. So this is the famous polar wandering of Alfred Wegener, and then came the plate tectonics theory, through which India moved northwards, as you can see. And about 50 million years ago, it strikes up, and then you have the mighty Himalayas, and this is where Antarctica gets placed. So what connection do we have with Antarctica? So India definitely has a huge connection with Antarctica. If you look at the East Antarctic and the Eastern Ghat belts, you can see that they fit in. They not only fit in, but I'm sure you would agree that certain rock types are also similar. So India is starting a major program on looking at the connection. And this year, a reconnaissance survey was done by Javed Beg, who is the Director Logistics at NCPOR, and Dr. Shailen Saini, the voyage leader for this expedition, who is still in quarantine at Goa. And they have set up the fuel dumps because this Emery ice shelf is quite away from the Indian research base, that is Bharati. So we call it an acronym GeoICE, that is the geological investigation of Emery ice shelf. So again, coming to, was Antarctica that cold? No. Now that we have plant fossil remains, we have coal seams that have been found, and this paper very recently came some couple of or 3 weeks back on frog fossils being found in Antarctica. So these are helmeted frogs which have linkages to South America. So we can say that yes, Antarctica was not cold long back ago. Antarctica is huge, humongous, and so is the science. But if you talk and ask anyone what is the currency of Antarctica, it is science. So science is the currency for Antarctica. So when did scientific research start in Antarctica? In fact, it started from the time explorers started going, exploring Southern Ocean and looking for Antarctica. Because in their logbooks, there's a lot of history recorded. However, this was the first brick and mortar station in Antarctica. This is the Ormond House, built in 1903. That was in the Laurie Island in the South Orkney Island, and this was made to house the Scottish National Antarctic Expedition members. However, interestingly, the Scottish never asked for a pie of Antarctica. There was a race. There was a race that every country, big countries, wanted a share of Antarctic piece of land. So who are the big players? It's there, up there: United Kingdom, Argentina, Chile, New Zealand, France, Australia, and Norway. But there is still an unclaimed land, very interestingly, because man is greedy, but still because this is highly inaccessible and unhospitable, this is very bad land. So it's huge, but still no claimants. However, This led to the IGY happening, that is the International Geophysical Year. So what happened actually? India in 1956, yes, in India in 1956, raised Antarctica at the United Nations. And because of India raising it, the warring factions like United Kingdom, Chile, and Argentina, who were fighting for the share in Antarctica, they kept backdoor meetings started because they wanted that they needed to quickly silence this, and that is how, and that is why the Antarctic Treaty was fast. So what happened with the International Geophysical Year? It was also the International Polar Year, the third International Polar Year, where 66 countries participated. And lot of huge data sets were generated. This led to the treaty signing. And the treaty signing was done on 1st December 1959, where, and now it is celebrated as the Antarctica Day. But however, it came into force only in 1961 in the month of June. So we had 12 original signatories to the Antarctic Treaty, but now there are 54 signatories. Seeing the huge data set that was generated, ICSU, that's a science body, decided to carve out one more scientific body to look into the science of Antarctica, and that was the Scientific Committee on Antarctic Research. So with IGY, and till today, a lot of stations all around Antarctica started coming up. So science picked up in a big way post IGY, and Earth observations started around Antarctica. So currently there are 70 plus stations, research bases all around Antarctica. And there are, in summer you can expect anywhere around 5,000 or more people, and winter there are 1,000 people which stay back for 12 to 14 months, manning the stations and doing the science that can be done during the dark winter period when the sun sets. Okay, so with this came another body, and that was the Council of Managers of National Antarctic Program. This came into existence from 1988, and the main purpose was to have the best practices for Antarctica, to look after the logistics in Antarctica, to look after the environmental issues of the research bases, to charter out the flights, to look into the ship channels that everyone is using. So everyone is on common page, and a template is circulated so that you know which ships are going when to Antarctica. And this is very important for search and rescue operations in the Southern Ocean waters. Well, as I told you earlier, it is a continent for science, scientific research. So the world started doing research in diverse fields, be it climate change, atmospheric physics, Earth observation, space weather, astronomy, to human physiology and medicine. Yes, human physiology and medicine is important because in Antarctica, you are living in isolation in sub-zero temperatures. And in fact, you will be surprised that many astronauts are sent to Antarctica to undergo isolation and training at research bases and to winter over. But why the scientists should go to Antarctica? Why it is important? Well, for me, it is the youngest continent. And I always say that you should have pride that once it is the youngest, and you think of your families, the youngest kid of the house is always loved. So once Antarctica is the youngest, definitely it is loved by one and all. It is largely untouched, undisturbed, and has a very unique ecosystem. And then you have linkages for climate. It's frozen all the year round, and therefore a lot of mysteries, lot of science has come out, and still a lot much needs to come out. And therefore I say, those who have innovative ideas, please join the Antarctic program. So what was that big thing that everyone knew in Antarctica was the ozone hole, and the culprit was the CFCs. So what did the CFCs do? We have been using CFCs. So it was the American scientists, Mario and Sherwood, and probably they were awarded for that because they said that CFCs played a key role in ozone depletion. But it was in 1984 by the British Antarctic scientists who looked at how the UV rays dislodge the chlorine atom from the CFCs, and they get attached to the free radical of the oxygen, and that forms chlorine monoxide. That leads to the depletion of ozone. So literally, it's not a hole, it's ozone depletion. So what are the units of measurement? It is Dobson units. So if you see this map, on the x-axis are the years and the Dobson units, and you would see that the ozone hole is decreasing in Antarctica. It is healing. It means things are going better. But if you see the projections, it may again increase. These are mathematical projections. But why? Why? Because after the Montreal Protocol in 1989 and 1990, why still are we worried about the CFCs? Just to tell you, those of you who not know, that CFCs have very high residence time, and that is about 150 years or so. So that is the problem. It takes time for the CFCs to vanish from our stratosphere. So, but we also have some ozone in our troposphere, and that is dangerous for our health. So these ozone is a protection for the Earth, so that the UV rays get protected. Otherwise, this could lead to a lot of skin ailments on the Earth. This is something interesting that happened. When we need to look back at Antarctica, you look at the history. So you have already seen the historical aspect of Antarctica. So now the scientific component of the past. For that, you need ice cores. Well, ice cores tell you a lot of history of the past, and this can only be obtained either in Antarctic or in Greenland, or even in the mountainous regions where you can take cores. Cores is nothing but a barrel drilled, that I'll show you subsequently in the later slides. So these are unique recorders which record in them the change in temperature, change in carbon dioxide, and depends what you look for, change in aerosols, change in dust particles, and so on. So if you look at the graph, on the x-axis is the time period in thousands of years, and on the y2 axis it is atmospheric carbon dioxide, and y1 is of course the temperature anomaly. What you see is there is a constant variation that is happening based on the different ice cores. The Vostok ice core goes back to 400,000 years, whereas the Epica ice cores go back to 800,000 years. So the lowest ranges would be about 170 to about 300 ppm of carbon dioxide. So around about 450 that you see this peak, and then you obviously get lower below levels as well. But the problem is now with the CO2 levels, this is not the CO2 level currently. It is past 400 now. So you can just imagine what will be the kick. This will be like a typical hockey stick, as they call it, and you would be seeing in the ice cores, which will be coming in decades from Antarctica, that there will be a big change that will be there. So is Antarctica really warming up? So let's see the recent reports. The recent report, which was brought out in February, March, is the Esperanza station recorded about 18.3 in the month of January, and this temperature on the Antarctic continent has risen by almost 3 degrees in the past 50 years. That is not all. So this was the first report, and what I'm going to show you is still worse. This paper came a couple of weeks back, which says that 2019-20 summer of Antarctic heat waves. So where is this happening? This 20 degrees point something was recorded at Mariambo station, which is again in the West Antarctic. So this is getting warmer definitely. So West Antarctic is warming up much, much faster. And these are the maps of November, December, January, and February. Okay, so now that you have seen that there is an alarm, so I checked with Bharati, the Indian station, and they said in January, the hottest day was about 7.7. And I then checked Maitri research base, and it was about 5.5 or so. So the stations in East Antarctica, the Indian research bases, didn't have this hot summer. But just think, if you have the summers there, then you would not require the overalls that you require currently, and the scientist and the crew would be all roaming in the t-shirts in Antarctica. Nevertheless, there are brave people who still do it for the photographs. Now let's look at the mass change that is happening in Antarctica. There's a huge mass change that is happening. This is the GRACE observation, that is gravity recovery and climate experiments. And in the red and yellow dark, these are the areas in West Antarctic which are losing mass. And the blue ones are where there is accretion of mass. So this is the major loss that is happening, about 125 gigatons a year. That's about 4 Olympic-sized swimming pools we are losing per second. That's a quote by someone, and I take it. So what is this mass loss doing? So we are losing a lot of shelf area, and that you all read. You have read about Larsen B, Larsen C shelf getting detached. This is the iceberg calving from the shelf areas. Shelf areas, remember, is floating. But this is a big one, that is D28 in September 2019, size of Greater London, away from Antarctica into the Southern Ocean. Well, after giving you a preview of Antarctica, now let's move quickly into the Indian scientific expedition to Antarctica. Well, the flag should always keep flying high, and this is the South Pole photograph led by Dr. Rasik Ravindra, which I'll talk later. The first expedition started in 1981, and the Prime Minister was very keen on the Operation Gangotri, and that is how the first expedition sailed off from Goa. Yes, from Goa. These are the pictures of 1981 operation, and this was a secret mission. But then remember, for various reasons. This also gave birth to a ministry that was the Department of Ocean Development, now called the Ministry of Earth Sciences. So the first expedition left the shores of Goa on December 6, 1981, on board Polar Circle. That was a ship chartered from Norway, and they landed in Antarctica on January 9, 1982. And they returned back February 1982, and that was a sojourn of 77 days. This was led by none other than Dr. S.Z. Qasim, who was the first secretary of the Department of Ocean Development itself. But the team had some wonderful people, which included C.P. Vora, the famous glaciologist, Dr. H.N. Siddiqui, famous oceanographer from the National Institute of Oceanography. Earlier, he was in GSI. And they did a lot of ocean work as well en route. And this gave way to the second expedition. This gave us the belief that yes, we can have our research base in Antarctica. Though a second team under the leadership of V. K. Raina left with very clear guidelines for the site identification of the first base, setting up communication links, and also trying to do some scientific research. This is the building up of Dakshin Gangotri, and it all started with the third expedition. This was led by Dr. Harsh K. Gupta, again a former secretary of the Department of Ocean Development, and Dakshin Gangotri, or DG as we call it, was built in a remarkable time of 2 months. And in 1984, January 26th, the flag was hoisted. We celebrated Republic Day. Within 2 months, the construction was over. This was a double-story structure made by Corps of Engineers of Indian Army. And the team came back, leaving the winter team, which was led by Lieutenant Colonel S.S. Sharma from R&D of MOD Pune. These are some of the prefabricated huts that were used for construction purposes. Now that this has further gone down and you cannot see anything except a plaque here written as the historical monument, HSM 44, if I remember correctly, is for the Dakshin Gangotri side. And there is a post office. There used to be a post office in Dakshin Gangotri for stamping. There is still one at Maitri. It was decommissioned in 1990, although it was not put to much use after 1988 because this condition was very severe. But however, it was used as a store and people used to come out through these vents. Maitri is, when this was going down, Maitri was being quickly thought about, and it was constructed in two years' time. And this is a station which is still operational, and this has been the mainstay of Indian Antarctic science. So in the 9th expedition, Dr. Rasik Ravindra was the first leader who became also the station commander. So earlier to that, there was a leader and there was a deputy leader. And the deputy leader normally was from the Indian Army, the senior most person from the Indian Army. And he would take over the station during winter and he would be called the station commander. So the 9th expedition saw a change. 9th expedition saw a change and a scientist took over the station, and that was Dr. Rasik Ravindra. A decade after Maitri, Antarctic Study Center came up at Goa, and this was called later as the National Center for Antarctic and Ocean Research, which was dedicated to the nation on 5th of April, year 2000. And the founder director was Dr. Premchand Pandey, who is now in IIT Kharagpur. So NCPOR now saw a new name in 2018, and it is now the National Center for Polar and Ocean Research. This was also the time when we switched our launch pad from Goa to Cape Town. So we started launching expeditions from Cape Town. The Antarctic Treaty meeting in New Delhi gave way, or the clearance, for constructing our research base in the Larsman Hills, and that was called Bharati. So how does Bharati look like during peak summer? It looks beautiful, like a spacecraft. Yes, it is one of the most modern stations that Antarctica can boast of, and India should be proud of it. This is, of course, the satellite links, and through which the ISRO downloads its polar orbiting satellite data and transmits to Sriharikota. So this was Bharati. And then how does it look like in peak winter? This is all in blanket of snow and ice. So Bharati is made up of 134 prefabricated containers wrapped around aluminium skin with about 6,500 square meters of footprint in Antarctica. And in fact, you can do troubleshooting sitting down in Goa itself of Bharati. And to speak, you can also talk on intercom directly without dialing an international number. That's the ease of having Bharati modernized. So coming to the Indian Antarctic program, it has evolved over time, and we call for applications under various heads, for which I am not going to talk much. Uh, this is obviously there on our webpage. And each year we come out with an application request in the month of January, February, inviting applications from institutes, organizations, and IITs, and so on for participating in the Indian Antarctic program. Till now, 39 expeditions and about 120 plus institutes and universities and organizations have participated, and about more than 2,000 expeditioners have been to Antarctica. So you can think of the humongous amount of achievements that Antarctica has brought laurels to the nation. However, this talk is not about the achievements of Antarctica. Nevertheless, I'll give you a flavor of the collaborative research that we have picked up, because we realize that with more and more collaborations, you can do much, much better, because uh, more the people, merrier it is in Antarctica. So this program is called the Sonic, which was just completed in 2019 December. And luckily the team was back before COVID, and the samples have reached already the Kochi Center. This is the longest lake core of about 8 meters. So this will take you back much, much to the interglacial times, because what we had earlier was 1.5 meters. This is an 8-meter core. So 1.5 meter went to about 40,000 years. So I'm sure this will go long back, but unless we have the dates, we cannot say something. So what is a core? You drill through pipes, and what you get at the top is the modern, what you get at the bottom is the oldest sediment. So this is the Indo-Japanese program that was held. And one other important program was the Indo-Norwegian collaboration about the bad ice, that is looking at the ice rises. This was a tough one. And they were looking at ice rises. So what are ice rises? They are nothing but the ice, maybe the ice shelf, where the flow is diverted around the grounded ice, and ice rises form. These are nothing but raised structures. So what are these doing? Why are they studying this? Because they need to understand the ice dynamics of Antarctica. This, if so, they were interested in doing ice rise, and therefore they were looking at this Indo-Norwegian collaboration. So what did they do? They looked at snow samples, they looked at ice, they looked at geophysical surveys, and it was a pretty hard task. So let's look at how does the ice core drilling take place. It's a tough job. It looks simple, and when the data comes, but it is a tough job, a logistical nightmare for not only the scientific team, but also for the logistic team, because you need to arrange so many things. And another nightmare is bringing these ice cores back to tropical conditions and preserving them at NCPOR in the ice core laboratory, which was again opened up in 2005. Okay, this is another collaboration. This is something for the society. Antibiotics from Antarctica. A novel molecule has been discovered. So we are working with the Foundation of Neglected Diseases Research, FNDR, and Anthem Biosciences. We have already 5 patents, and we are into the animal trials. And we hope, because of COVID, it has got delayed. We hope that by next year mid, we'll be into the human trials and try to look at possible solutions to enhance tuberculosis. So the journey to Antarctica. Quickly, I will ramp up my presentation as my time is squeezing on, and I've got a habit of talking more. From Goa to Cape Town, now we are flying from 1999 onwards. It's 8,000 kilometers. From Cape Town, we have a ship going to Bharati station at Larseman Hills and flights going to Maitri. So this is a logistical challenge for the operations team at NCOR. Every year it's a logistical challenge. This year it was COVID-19. So once your proposal gets through, you get thoroughly checked at All India Institute of Medical Sciences at New Delhi, and then you have to go through the pre-Antarctic training at OLI. This is very, very important and critical, as you understand the life, how will support your life in case you have problems. Then you develop camaraderie, and then you are given a lot of talk there, how to save yourself in difficult situation. Of course, you have climbing as well. And once you reach Cape Town and you board the ship, this is an emotional scene when you are leaving. But I'll leave it how tough it is when you get ready on the ship and moving into the roaring 40s, the furious 50s, and the screaming 60s. This will give you a glimpse of about 30 seconds. So these are real rough seas, and it's never easy to do science there. So these are icebergs. As you move ahead in Southern Ocean, moving past 45-degree, 50-degree, you will see a lot of icebergs welcoming you. You will see pack ice sheets as you move closer to Antarctica. Then the ship is ramping up, getting much closer to the shelf, as close as it can get. And then you have the vehicles that you can see all around, which will help us to take the supplies to the research base for the survival of the team there. So we now have flights run by ALCI, that is Antarctic Logistics Center International Consortium of countries, which operate in the East Antarctic Central Dawning Maudland. And there are regular flights that we charter from Cape Town to Antarctica, say about 6 hours if the weather is good. And in fact, it was in 1928 when the first flight by Sir Robert Wilkins took place, and after that, it is history, and the man has never looked back again. Another important event that happened to celebrate the centenary of Roald Amundsen was the first South Pole expedition, which was led by Dr. Rasik Ravindra, and these are Toyota modified trucks. These were used to go to South Pole expedition from Maitri Station, and this was the team with Rasik Ravindra, Ajay, Dr. Pradeep Malhotra, Dr. Thamban Melod, Ashit Swain, Javed Saab, the logistic manager, Ajay Dhar, a veteran. We have Surat Singh and Krishnamurti, the supports for the fabulous supports for Antarctic South Pole expedition. Antarctic is a challenge, and you can see the ice burns, and you can also see the ice and you can also see how the piston bullies, which are used for transferring men and material, stuck up in a big blizzard. So, but then some people say it's the coolest job, but it is risky. So you have to take risk if you want to enjoy life. And these are the beautiful pictures from down under, the world's coolest job, as we call it. So again, if you have, this is the latest picture from February 2020. And if you have a science proposal with a spark, then you can surely join us for the Antarctic science. So this says it all. So if you have the spark, you can. So now it's an enjoyment if you are there in Antarctica to see the auroras. This is also being studied by NCPOR through the all sky cameras and IIG, which is looking at the geomagnetic field. You have life as seals, you have the leopard seal and the Weddell seal. They have a lot of fat, as you can see, and blubber. So they can survive in the cold, and they love ice. And the only predator that they are afraid of is the big whales. Otherwise, they are very happy in Antarctica. So there's no one to trouble. They are mammals, and they give birth to young ones, and that takes about 9 months, and a single pup is born. Then there is a predatory bird, that is skua, that is being studied by a university. We had a proposal which just got over, trying to look at the ecology and the breeding habits of skua. The Wildlife Institute of Dehradun is studying penguins and is also looking at the snow petrel history, putting up cameras to map the hatching and how it behavioral patterns. The penguin population is also being studied. Penguins are different types. There are 17 known penguin types, but penguin is a very social animal. I'm not going to talk much on penguins, but there are only two penguins which are found closer to our research bases. That is in Antarctic, Bharati, and that is emperor penguins, the bigger one, and these are Adelie penguins. So there is again a project on the social networking of penguins by the Ministry of Earth Sciences. So enjoy the next video for a couple of seconds. These are the Adelie penguins, and you could hear the noise as well. So they recognize each other by the help of the sounds. Well, there are no trees in Antarctica anymore. If you look back, yes, there were surely some trees in the forest. But now that you have summer, that you can see patches of lichens, which are symbiotic relationship with fungi and algae, but they grow very, very slowly. When I say very slowly, I mean to say that 1 centimeter per 100 years. And when the situations are pretty worse, they can even grow at 1 centimeter per 1,000 years. But then this is the beauty of Antarctica. A lot of lichens and a lot of microbes which I have not talked about. So the take-home message from here is this slide, because we'll be celebrating the World Environment Day on June 5th. So please take care of the Mother Earth, because if you don't take care, this could happen. So the penguin is saying, I didn't wear this, folks. I just swam across the ocean with all the plastics. So yes, plastic is scary, and it is also reaching Antarctica. With this, I would like to end with a slide. I want to give a tribute to all those men who have dedicated their life to the icy continent. We have lost 6 beautiful lives in Antarctica from India. I don't know world over how many lives we have lost in Antarctica. It is to salute all the people involved in the program since the inception, some 40 years ago. There are scores of men and women who work behind the curtains to make this program a success. All the expedition members and the organizations will feel proud to be the organization chosen to run the Indian Antarctic program, and I need to thank the Ministry of Earth Sciences for it. And with every failure, we learn a new lesson. One needs to be brave to take up science and logistics in Antarctica. Thank you, and Jai Hind, and thanks for joining the webinar.
Thank you, Dr. Rahul Mohan. That was a very fascinating presentation. We all enjoyed. And here are some questions for you. So I have kept it in your chat window. So kindly read the question and address.
Sure. Okay, so interesting questions. Always, Antarctica is interesting, but I hope that I can answer some of them. In case I'm not able to answer, please feel to send me mails. Is ancient Antarctica or lost civilization? There was never a civilization in Antarctica. There were definitely animals, and there were definitely plants that were there, but there was no civilization. Coming to the next question, in 1985, teams of scientists of NASA and British Antarctic Survey discovered severely damaged of sections of Earth's ozone layer of Antarctica. Why that's a problem? Well, that's an easy answer. I've already explained that it was largely due to the chlorofluorocarbons, or the CFCs, and because during the cold winter nights in Antarctica, the stratospheric temperature can go to minus 100 degrees. So that when the spring comes, you have the light coming in. That is the time when these CFCs, which are resident long time in the stratosphere, get attacked by the light and they break into the chlorine monoxide that kills the ozone. And that is not a hole. Remember, it's depletion of ozone. What is the source of silicate for diatom frustules in the Southern Ocean and the Antarctic Ocean? How silicate became rich in that part of the ocean? Very good. Very good question, I would say. When you look at the profile of the Southern Ocean, you see that there is a carbonate ocean and there is a silicate ocean. If you divide the ocean, once you leave from India to Antarctica, you can divide the ocean into two parts. So from where did the silica come from? Silica requires a lot of phytoplankton blooms, lot of material in the form of iron, micronutrients. From where does it come? It comes from definitely broken away parts of Antarctica and the land derived things. And of course, biological productivity played a key part, as also the nutrients for the growth of these silicates. Today, we are concerned about the greenhouse gases because it increases global temperature via radiative forcing. But in the past record, the past temperature leads PSU. What is the reason for this? Very good question. We really don't know much about uh, uh, that why that PCO2 the temperature leads the PCO2. Why the temperature change? Because we need to look at holistically into not only temperature, not only PCO2, but we need to look at tectonics. We need to look at ocean gateways. It is a holistic picture. If you look at only one module, you will not get an answer for this. So you need to look holistically into the picture of why this happened. I don't have a full answer, but I'll surely give you answer on email if you would desire. Why is the Western Antarctic warming and losing much ice? Much easier question to me, because Western Antarctic is much thinner ice sheets. If you had listened to some of my slides that I showed, East Antarctic is voluminous. Number one, it's like they say that it's a marine part of Antarctica. That is what they talk in loose terms. So definitely, Western Antarctica is warming, and that's a sign of worry. But be rest assured, Antarctica, if we take care here, we need to take care of where we stay so that Antarctica and Arctic stay safe. And that is very important. So this Environment Day on June 5th, may I request all of you to start caring for your Mother Earth. With this, a big thank you to all those who joined for this webinar, and thank you so much for joining in this webinar. Thanks a lot.